Good morning, Tamina Khan is here in TKMaths is fun. In today's video, which is video number 4 on the topic function, which is the part of the syllabus of O-level Advanced and AS level mathematics. As I said earlier, the first 4 videos are same for AS mathematics and for O-level Advanced. From video number 5, it will be different depending on what part of the syllabus is specifically in each grade. So before we start inverse function, you can see here my blog address and website address. You can refer it to watch more videos. In the first 3 videos, we have covered these topics. First video was only on the definition of the terms. Second video was on the domain and range of a given function and its sketch in terms of linear and quadratic function. Third video was on composite function. Now this video is on inverse function and its sketch. So let's begin. What is an inverse function? How do we write it? And things like that. So inverse functions notation is this. You can see it here. F power minus 1 bracket root x, depending on the variable we are using in the function. So it basically reverses whatever you have done, right? So let's see the procedure. How do we find the inverse function? There are certain steps. If you remember them, you can follow it and you can find it out. So function let fx is equals to y. After that, I will take an example, a specific example to show you. First of all, I'm telling you the steps. Once you will put the function equals to y, then you replace x by y and y by x. And after that, you make y a subject in terms of x. And what you get is your inverse function. So let's see the example here. For example, I will come back to this point. For example, your function is 3x minus 1. So first step, put it equals to y. So y is equals to 3x minus 1. The next step is to change y into x and x into y. So it will become this. Third step is you make y a subject in terms of x here. So what you have gotten is your inverse function. So you can call this as my inverse function. Now, very important thing about inverse function is that it only exists for those functions which are 1 to 1. And I will tell you with the help of a few diagrams why it is said so, right? So, and I will also tell you a few interesting things about it in later slides. Right now, we have just seen how to find the inverse function. This is the example of linear function. We have to take special care of quadratic, and I have taken few examples of that also, right? Now, for example, if you see here, this diagram, which I have shown you in my previous videos, is representing input and output, right? Domain and range. For every domain, there is only one range, which is specifically defined function, right? For every domain, you should have exactly one range. In this example, if you see, for this domain, you have exactly one domain. Perfect. For this, range. For this domain, you have only one output, one range. Perfect. It's a definition of function for fulfilling it. For this input, you have only one output. So that is also fine. Now let's see, we know that this is one-to-one function and this is many-to-one function. So let's see why this has an inverse and this does not have an inverse function. Okay, so let's see. I'm just taking a different color here to make it prominent. So for example, I go from here because in the inverse function, it reverses. So if I go from here, or if I go from here, if I go from here, right? So if you notice, for every input, now in the inverse function, this is your input and this is your output. For every input, you have exactly one output. So it is fulfilling the definition of a function. For every input, there should be a unique output. Now let's see in the second diagram. For this input, you have this output and you have this output. Now, and for this input, you have only one output. That is fine. But in this case, for 7 as an input, you have two outputs. So in the inverse function, it does not fulfill the definition of a function because function says for every input you should have a unique output, but here we have two outputs. So that's why For inverse function, the function has to be 1-to-1 function, right? Sometimes you write like this also. So for function, inverse function, you should have 1-to-1 function. Otherwise, inverse will not be existing. Now look at this diagram. If I ask you which diagram has an inverse function, what will you say? This one only, right? Because it is 1-to-1 function. In case of many to one, this is definitely not a function at all, so forget it. Many to one, if we have any such function and we want to find its inverse function, then we have to restrict the domain. For example, if I have taken this part of the diagram only this part, for example, right? And forget about the rest. Means I'm restricting the domain from here till whatever I take here because it is extending in this direction. So if I restrict the domain, then function is 1-to-1. Or if I take only this portion before the turn, right? Then also I can say, yes, it has inverse function for this domain only. So whenever you have many to one function, you have to restrict the domain to make it 1-to-1, and we will see the examples, right? So let's start. Okay, for example, this case, quadratic function. Right now, it is not 1-to-1 function, right? And if I take x greater than 0, it means only this part of the function. If I take only this part of the function, diagram is not very perfect, but just focus on what I'm trying to say. So if I restrict the domain and I said I'm taking only x greater than equals to 0, then it means my range is what? The value here is 1. So it means my range is x greater than or equals to 1. Now for this part, the function is 1-to-1, and I can say, yes, its inverse exists, right? And I will show you through diagram also later. In this case, the very interesting thing, if I ask you, what is the smallest value of k such that x greater than k? What I'm trying to say, what is the smallest value of x so that the graph is 1-to-1? Now, values of x are, for example, 0, 1, 0.5, 1.5. So which values? I know that from here the division happens, right? If I go to this side, the graph is 1-to-1. If I go from here, the graph is 1-to-1. If I take this part of the graph from here, it is 1-to-1. So what is the smallest value of x? Which is 0. X is equals to 0 is the smallest value for which the function will have 1-to-1. The same question can be asked, what is the greatest value? So now you will talk about this part because I'm saying x less than k. It means this is the greatest value of x with respect to the values of x which are here. So this part of the graph is also 1-to-1, and the greatest value of x is 0. So the same question can be asked in two ways. Now, another very important thing about the function and its inverse with respect to sketch, they are reflection of each other in the line y equals to x. So whenever exam or question asks you to draw function and inverse function and show the relationship clearly, you will simply draw the line y equals to x and try to keep scale same. You see the distances I'm taking on the x-axis and y-axis is same, so that your line y equals to x makes 45 degrees. It is estimated, not exactly measured, but sensible thing, right? So when you draw the function and you have to draw its inverse function, you just reflect this in the line y equals to x. And this is how you can get function and inverse function sketches, right? We will go into the detail in the last example 3. So very interesting thing, if you notice here, this point is 1, 0. In the reflection of the line y equals to x, the point will be 0, 1. So what did you notice? For the function, whatever is your domain, that become range of the inverse function. and whatever is your range in the function becomes the domain. So in short, we can say the domain of inverse function is the range of function, and the range of inverse function is the domain of function. So this is the meaning of it. You just need to interchange x and y values, which are your domain and range in the function and inverse function. So it becomes, it makes your plotting also or sketching also very easy. Now this is just another point that self-inverse function means your inverse function and function are equal to each other. If I take an example here, it is of 1 over x. If you try to find out its inverse function, it will be same. In such type of cases, we call the function is a self-inverse function. This is just for the piece of information for you. Let's take this example. I have taken 2-3 examples here. This is your function. You have to sketch it in the, you have to sketch its function and inverse function, number 1 part. Number 2, you have to find f inverse x. This is an extra information given. Mostly this information is not given in the question, especially in exam paper. This example I have taken from a book. And then you have to check this relationship. Is it same or not? Now for some people, this is little strange. Please remember, composite functions can be written like this or can be written like this, right? So you should not get surprised. This is just another notation of a composite function. So let's just start with part 1. If I want to draw inverse function, I need to draw function f. So I will simply sketch the line 2x plus 3, which is very easy for all of us. You just need to take 2 points and then sketch it on the graph. Rather, 1 point is sufficient because 1 point is on the y-axis. You know, this represents y-axis coordinate, y-intercept, sorry. So you can take 1 point from here and another point. Okay, and exactly the same thing is done here. And for the inverse function, we are interchanging the points. So when you are sketching it, this is how you will sketch it. And you can see the line y is equals to x is exactly passing through the center so that it looks symmetry then, right? The next part of the question was saying, find out inverse function, and then we will check this. So when we are finding out inverse function, the technique is same. Replace x by y, y by x, and then make x a subject, y a subject, sorry. We have replaced x and y. We are making y a subject, and the function we got is our inverse function. The last part of the question was saying, prove that this is equals to this. So let's see here. First of all, this simply means f is a composite function of f inverse x. So we have f inverse x here. We are substituting here in function of f, right? What was your f? Y is equals to 2x plus 3. So in place of this, we are writing this, right? In place of this. This is exactly what we are doing here. And in this case, now what we are doing? We are substituting we are substituting, just a minute, function is, yes, 2x plus 3. So we are substituting this here because now your f of x is going inside f inverse. This is what we have studied in composite function. So you will plug in here and you will simplify and you realize that, oh, this is same, right? So what did we identify from here? That f inverse x is equals to f inverse of f of x is equals to x. So this is what we have concluded from here. Now, this example is same, exactly same what we have done, only numbers are changed. What I want to show you here is that why I am emphasizing that your line y is equals to x should be exactly in the center at 45 degrees. Otherwise, what difference will it make? So look at this graph. This is the graph of the equation y is equals to 2x plus 5 and its inverse function, right? This is your function line and this is your inverse function line. If I ask you to look at this closely and compare with this one, what do you notice? Anything? This graph is symmetry, this is not. Why? If you notice here, just a minute. Okay, if you notice here, this distance and this distance is same, right? Similarly, if you notice here, this distance is not equal to this distance. So this is not symmetry, right? So it does not look like reflection. The points you have taken is not giving it a look of symmetry. So you have to be careful that you keep the axis same, and then the line y is equals to x is at 45 degree, like here it is not at 45 degree here. So if the scale is same, like your 1 is this much, here it is your 2.5 this much. So keep the scale same, then diagram of reflection and inverse function will be same. Function and inverse function, right? So let's see the last example. This is little tricky. Earlier example was on linear, now this one is on quadratic. We know when we are finding out inverse function of quadratic, I told you we have to check the limitations of the domain. We have to select a domain for which the function is, for which the graph is 1 to 1. Okay, so first of all, we will change this quadratic equation into completing square form. We have already seen in a previous video, so I'm just showing here you how it is converted. So you got x minus 3 square minus 7. It means 3 and minus 7 is your turning point. 3 comma minus 7 is your turning point. And I told you earlier that if your x coordinate of the turning point does not fall between the domain of function given to you, this is the domain of function given to you, this is not in between them, rather it is at the edge, then you don't need to worry about. It means this domain is perfectly defining this function for 1 to 1, right? And if you plug in 0 in this equation and 3 in this equation, you will get the values of range straight away. We have seen this thing, right, in domain and range case. So now to find the range of the function, I will see what are the values at these extreme ends. So when I put x0 here, I get 2. So with 0, I get 2. And when I put 3 here, I get what? Minus 7. If I show you the sketch of it, the sketch of this function overall, for this domain, it means we are talking about only this part. Let me use some other color. It means we are talking about only this part, because we are saying 0 to 3. This is my 3 value. So between 0 to 3, it means I'm talking about only this part of the graph. And what are the values of y on this part of the graph? If you see, this was 3. Sorry, this was 0, so 2. This was 2, and this was 7, right? So my range is from minus 7 to 2, okay? So you can write the range of the function is minus 7 to 2. So you don't need to sketch it here, because you have checked that the x coordinate of the turning point is not in between the given domain. You can straight away substitute these values in the function and get the y values that will define your range. What is the domain of f inverse x? Without doing anything, you can answer this question in a minute. We have just seen that domain of f inverse x is the range of function, because they interchange the values. It means the domain of f inverse is this, because this is the range of the function, right? So this is how you will write that the domain of f inverse x is minus 7 to 2, which was the range of the function, because they interchange. So we have seen here that for function, this is domain and range, and for inverse function, it is exactly the reverse of it, inverse of it, interchange it, right? So part B, find an expression for f inverse x. Now this is something very important. It's not as simple as is the case of the linear function. Whenever you have a quadratic function given and you have to find its inverse function for some domain, the first step you have to change it into the completing square form, which is done here for you. So now, if it is not given, you will find out yourself, right? So now you have this completing square form of your quadratic function. The next step of the inverse function is make x a subject. Replace x by y, y by x, and then make y a subject. So after replacing x and y, I have to make y a subject. So what I will do next? I will take 7 there and I will take a square root on both sides. Now when you will take a square root on both sides, you will have plus minus. Now this is your inverse function. Now you will take plus sign or you will take minus sign. Very interesting thing. Right? Now this thing gives you the value of y, right? For the inverse function, it gives you the value of y. Now if I look at this here, my values of y should be between 0 to 3, right? My values of y should be between 0 to 3 for inverse function. So if I will add something in 3, it will cross this limit, because definitely whatever the value of x I take here, if I will add in 3, I will have value more than 3. So I will take 3 minus. Only then it will keep me within this range, right? So this is how you define what value you will take from here. And the next part and the last part of the question is saying find f inverse x. So you already have this as the inverse function, and you will substitute it in the function. What was your function? If you remember, x plus, we have changed it here, x minus 3 square minus 7. So we are just plugging in here because it was x minus 3 whole square minus 7. So we are substituting this inverse function in place of x in the function and simplifying it. Right? 3 will cancel with 3. You are left with this square will cancel it. So you will get the answer. And this is the last thing, the reflection of it in the line y equals to x, because question is saying sketch the graph. So this graph was already sketched here. This point was 3 minus 7. It will become minus 7 comma 3. This point was 0 comma 2. It will become 2 comma 0. In the line y equals to x, you reflect them. So this ends the video here. In my next video for AS level students, it will be domain and range of a composite function. We have not seen the domain and range of a composite function so far. And for O level student, it will be about modulus functions, right? So thank you very much. Press like and subscribe if you have learned, and if you have enjoyed, share it with your friends. Thank you very much. Take care.